Welcome, all of you Algebra 1 students. All right, so we've been starting to talk about patterns, and we've specifically talked about linear, quadratic, and exponential patterns as those types of equations we're going to be studying throughout this upcoming school year. So let's take a look at these patterns that you see right here. And you can turn to page 11 in your workbook. That will help you to perhaps take some notes with me. So if you're not on page 11 in your workbook at this time, you could pause for just a sec and grab that. And perhaps yours looks a little bit different than mine, but go ahead and get the same information into that spot. Okay? Play with all these pens here. Okay, so if you've had a chance to grab your workbook, one of the things I'd like to show you and remind you about linear patterns, when you have a table, you can tell that the equation is going to be linear because the first difference is constant. So right here you see a pattern from 5 to 10 to 15 to 20, 25, it looks like we're adding 5 each time. And in fact, we are. Okay. And this is not the graph of these particular points. I apologize for that, but this is simply a graph of a linear equation, so we see a straight line. But what you notice is if this first difference is always adding or subtracting, so if you are either adding or subtracting the same number from those y values, that's what you see in terms of your pattern, then you know that you have a linear function. So it is going to be a function of the form y equals mx plus b. And we know some important information from this table right here, this 5 that you see, because it's going up by 1 on your x values. Your slope is actually a change in 5 over a change of 1. So that makes our slope 5 over 1, or 5 for this particular pattern. And then you also see right here this value of y for where x is 0, and that is going to be our y-intercept. So we're able to actually know our y-intercept from this table as well, and you can write your equation. So that's going to be one of the things I'm going to want you guys to be able to do. So recognizing that pattern for adding and subtracting as a first difference. Okay? So let's move on to our next, the quadratic right here. And quadratics are going to be in the form y equals x squared. That's the parent function for the quadratic. And it's going to have an x squared term sometimes, or every time, and possibly an x term in the formula, and possibly a constant. Okay? And the way you can tell it is a quadratic is if the pattern is U-shaped. See this U-shaped graph right here? Okay. And once again, the pattern that I have written here does not match our graph. It's just simply another way to show that is a quadratic. And let's see if we can determine a pattern here. It looks like right here we could see we're adding 5 each time. Let's see what we're adding here each time. See if it's the same. Let's see, we're adding 1, we're adding 3. Uh-oh. It's not the same. We're adding 5. We're adding 7. But I do see a pattern here with this 1, 3, 5, 7. So if you go to the second level, or what is called the second difference, and you see a pattern, that is going to make it a quadratic. So let's see if we see a pattern here. It looks like from 1 to 3 I added 2. Okay. From 3 to 5 I added 2 again. Okay, that's looking good. I added to again. So if you wanted to find the next term in the pattern, it looks like we would go, let's see, 1, 3, 5, 7, 9 would probably be the next value, which means our next value of our y term is going to be 18 plus 9, or 27. Okay? So that's how you can tell it's a quadratic, that U-shaped curve. Let's come up here and grab a completely different color for this last one. An exponential curve. Okay, so an exponential gets really big really fast. The curve looks like this. It could go from really small really fast and grow super fast. It also could start really high and come down low really fast. So there are different ways that your exponential can look. And typically you have a starting value. We'll just call that starting value A. And then a growth number that you're multiplying by. We'll call that value B. And then some variable. Okay, so let's look at this pattern. Let's see if we're adding the same thing each time. Let's see, we're adding 1, then we're adding 2, then we're adding 4, then we're adding 8. That doesn't look like it's going to be adding and subtracting the same number each time. And in fact, the second difference isn't going to work out on this one either. But what you might try thinking about is there a number that you're multiplying by each time? Are you multiplying or perhaps dividing by a number each time? If that is the case, then your graph is going to be exponential. So let's see what we can come up with here. It looks like 1 if we did, now remember a dot means multiplication also. So 1 times 2 is going to give us that 2 right there. And then look at this. 2 times 2 will give us 4. 4 times 2 will give us 8. 8 times 2 will give us 16. And so in fact, our pattern it's not a question anymore. Our pattern is multiplying and dividing. Okay? So those are the patterns I'd like you guys to look for as we're thinking about linear, exponential, and quadratic patterns. All right? And you guys are going to be using this information to work on pages from your workbook. The ones that I would like you to make sure you take a look at, I think they start on page 11 and go to perhaps page 13. Okay, we'll double check on that in class. Okay, but anything that is showing a pattern of graphing or identifying patterns in tables, that's what I want you to finish on pages 11 through 13 from your workbook, guys. All right, excellent job. I will see you in the next video.